Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AFIQ bin NORLIZAM. I'm from Group 6, want to present the conversion of Copperas to Polyferric sulfate and its application for selected wastewater treatment. Copperas is a natural byproduct manufacturing Veneto-Asia syndrome Berhardt's titanium dioxide, which is a pure white powder derived from a simple inorganic chemical. It is a silvery white substance with low density, excellent strength, good corrosion resistance, low thermal and electrical conductivity, and paramagnetic properties. The overall goal of titanium dioxide manufacturing is to turn impure titanium ore concentrate into pure white titanium dioxide pigment. The sulfate and chloride procedures are two separate processes in the titanium dioxide synthesis process. Both procedures start with titanium dioxide as an impure mineral input. Copperas, on the other hand, were mostly made by the sulfate method. The sulfate process uses a variety of feedstocks such as ilmenite, titanium slag, or a combination of those minerals, which are digested with concentrated sulfuric acid. This method was used to obtain titanium dioxide pigment. Because of its simpler technology and lower grade and cheaper raw materials, the sulfate process is the most used method for manufacturing titanium dioxide, as opposed to chloride. This is sulfate process of titanium dioxide production. Characteristic and properties of Copperas. Copperas is a commercially accessible inorganic coagulant that is less expensive than alternative coagulants such as synthetic polyelectrolytes. It is the cheapest of all the salts that may be used for coagulation. Copperas can help remove the pollution by acting as a coagulant. It is a positively charged molecule that attracts the negatively charged counter ions in colloidal solutions, forming tiny flocs. Copperas is a crystal solid that is turquoise or blue-green in color and odorless. The copperas' yellowish color reveals that they have been exposed to the air for a longer time. Copperas must be kept in airtight container to prevent oxidation and maintain its greenish color. Copperas has a melting point about 68 degrees Celsius and a decomposition temperature of more than 300 degrees Celsius. The salts are water-soluble. When reacting, they tend to lose or gain water molecules depending on the medium. The aqueous complex is formed when ferrous sulfate salts are hydrolyzed in water. When these salts encounter air, they lose water molecules.
Okay, next, I, Muhammad RAZIQ bin Muhammad NIZAM, will continue to present about conversion of copperas to polymeric sulfates. The oxidation of ferrous sulfate to ferric sulfate in very acidic condition using the oxidizing agent, which is nitric acids, begin the manufacture of polymeric sulfate, as shown in step below. And when the amount of sulfuric acid available is limited, the hydroxide ion will replace the sulfate ion during the hydrolysis stage, which is resulting in polymerization, shows in step 2 and step 3. Okay. The polyferric sulfate is made from ferrous sulfate, but its physicochemical properties are significantly different. The melting point of ferric sulfate is 175 degree when the relative density is around 2.1, and 190 degrees Celsius when the density of polymerized ferric sulfate is 2.44. The polyferric sulfate is a macromolecule polymer, whereas the ferric sulfate is a low molecular inorganic. As a result, the chemical reaction outcome will be different. Its coagulant effect in all type of wastewater is superior to other coagulants. The hydrolysis of polymeric ferric sulfate form a long chain like colloid with a strong absorption force and sedimentation net trapping effects. And lastly, its treatment effects on phosphorus removal, sulfur removal, bleachings, and suspended solid, also chemical oxygen demand removal in wastewater are excellent.
Assalamualaikum warahmatullahi wabarakatuh. My name is AMRAN bin Muhammad ZAKERINI. Today I want to present about application of Copperas in wastewater treatment, which is coagulation and coagulation process. Coagulation and coagulation process is one of the many wastewater treatment process that has been employed in the both urban and industry setting. Okay, coagulation and coagulation in wastewater or water treatment entails adding chemicals to change the physical state of dissolved and suspended solid, allowing them to be removed more easily during the sedimentation process, which is the physical and chemical process between the water alkalinity and water coagulant, which contribute to the formation of insoluble flux, known as coagulation. To reduce turbidity, natural organic matter, and other soluble organic and inorganic contaminants in wastewater, the procedure aggregate fine particles and collide into the bigger particles. It is divided into two stages, which is quick coagulant mixing into the wastewater and water to be treated by vigorous agitation. And next one is coagulation by slow agitation for the collection of tiny particles into flow. This is a figure that shows the coagulation and coagulation mechanism. First is chemical will be introduced to the water or wastewater to simulate the aggregation of suspended solid into the big particles so they can settle or be easily removable. Coagulation is based on integrating particle with the opposite charge to neutralize electrostatic repulsion. As the coagulant was applied to neutralize the charge on the particle that will be agglomerated to create a flux and promote the clearance of colloidal particles.
As a conclusion, Copperas, a byproduct of titanium dioxide manufacturing process, has potential to remove a pollutant from several types of water or wastewater. Copperas, which includes a high concentration of ferrous oxide and sulfur trioxide and can create flux, can be used as a coagulant. Copperas, a low-cost coagulant, can be used alone or in combination with coagulant assistant. Lastly, Copperas is readily available in Malaysia and it is cheapest product than current alum.